So now in the same case, we can apply the KNN based predictions. Now here I'm just showing with the training data set. So again, I'm just renaming this part, that KNN training part. So this was linear regression. And testing data set, this is linear regression. So here, how we can predict with the help of KNN. So again, same data set, I'm just copy over here for KNN based regression. And from the testing, I'm just taking the same data set. So here I'm just again renaming it KNN regression training. So what is the main concept of KNN based regression? It generally tries to predict based on the neighbors. Or now there is a catch, means how it is predicted. So basically we have to select an odd number of neighbors while training the model, and based on the average we have to just find out the value or predicted value. Now if I just write over here the distance, as already mentioned previously, that this similarity or these neighbors are identified based on the distance from the particular point where you want to just predict the value of your outcome based on Euclidean distance. So here I'm just writing once what is the formula for your Euclidean distance. That is nothing but square root of here we have 4 features, so definitely, so x1 minus x2, or let's say here x1 minus x2 square plus, by the way x1 is the first feature, then y1 minus y2 square plus z1 minus z2 square plus, I'm just bringing another one because we have 4 features over here, so m1 minus m2. Then you are taking the square root. So by using this formula we can easily calculate the distance between the variables. So now here I'm just removing this equal to sign to keep the formula intact. Now the same way I will approach this problem, and I will try to calculate the distance from a particular point. Let's say I have to predict for the first case testing data set. Here only we have So just copy paste, let me first. So for the first case, in the sense, we have budget of 15 crores and YouTube views of 6086811 and YouTube likes of 26560 and YouTube dislikes of 1647. So for this case, I will just try to predict. So here, this value I will copy and bring over here for the training part. Now here I do not know what is the value of the box office collection, so that need to be predicted. So here first let me just calculate the distance first. So here how I will calculate the distance, so SQRT, then so mind it, this will be the fixed value for the particular instance where I am trying to predict the value, so you just keep it fixed, then minus 12 tick square plus again for the next, again you fix that, minus C2 tick square plus again dollar, here it will be D107 minus D2, then tick square plus dollar D, okay, D, it is E, ABCDE, so again 107 minus E2 and tick square. Finally you have to just close the bracket. Okay, so something is there but I missed. Okay, double bracket I have to just put over here, and the entire formula should be within the square root. Okay, so this is the distance. Now I will drag it for all the training instances. Now what I have to do, I have to find k nearest neighbors. So now I already told that it will be even number. So let's say I'm just considering only top 3. So in that case, I have to rank these values or rank these distance based on ascending order. So it will be rank, the formula you will be using, then the particular number, this number, and your reference. Basically you are considering all the values that you have calculated, then comma, then you have the two options, 0 for descending order and 1 for ascending order. So we are looking for the ascending order, so we will consider 1 and just hit it. So you will find the rank is provided over here. Now here you have to just select the top 3 for prediction. Let's say if I define the case 3, so here k equal to 3, then my top 3 points I have to just find out what are the values. So I'm just writing 1, 2 and 3. So if I just rank or just arrange these values based on the rank, so you will find I'm just using the custom short, and okay, so I have selected the wrong thing, so I have to select entire data set. So let me just select the entire thing. Rank smallest to largest. Okay, 1 minute. So this value I have to first fix because they are dependent. So I'm just again fixing these values, numbers. Now delete this. No need of this one. So now I can rank them. Again, custom short, rank smallest to largest. So these are the points where we have the lowest distance. So first prediction is 56, so I'm just considering 56 over here. Then we have 59, then we have 64. So my prediction is, as per this, so here I can write my prediction equal to average of these three. So 60 is the predicted value. Now this value you can keep over here for the testing. Now, if same thing you can perform with 5 nearest points, in that case, if k equal to 5, then you have to consider the top 5 points or nearest 5 points. 1, 2, 3, 4, 5. So here I can take top 5 values and same average value I can calculate. So predicted value equal to average that is 145. So again, if you increase the n or k value, so same value, this is for k equal to 3, k equal to 4, k equal to 5, equal to, can write 145. So with the changing value of k, this prediction value actually changes. So now, as per your requirement, or let's say if you have created a KNN with 3 neighbors, you predicted all the values, then you can find out the same R-square value and RMSE value and try to find out which model is better, in the sense, in terms of lower RMSE value and higher R-square value or coefficient determination value, and based on that you can select your best model out of it. So this is one example how KNN and simple linear regression model can be used to predict any value based on the features. So this is the end of demo of regression. So now the two sheets will be available with the course. So at the end of the demo, we will show how the results actually are for, let's say, for k equal to 3, k equal to 5, and also the results from linear regression for the same model. So it will help you to understand how this supervised model can be used to solve regression type of problems.